So good morning or good afternoon or good evening or good very early, depending where you are. Thanks for joining this edition of Commodore User Europe. I see that we are quite a little bit of viewers here on the Zoom call, and we have currently 4 people on the Facebook Live. That's fine, I would say, for a start. So this is the first meeting that we do this year, 2022. I hope you had the chance to look at the previous events, as you probably know that they are all recorded and available from our Facebook page. Then you have access to the whole recording, and each of the talks are individually recorded and made available on our YouTube channel, actually. So the agenda for today, so you see it on the website. We start with Javier with a topic on a BBS, petscii compatible BBS written in Python, if I'm correct. Then we will have an emulator. I don't know in what it's. Java-based emulator for Commodore 64 128 by Will. A command line interface. I don't know how to pronounce this. chiCLI or something like that from Chiron later on. He will explain to us. Marcus will introduce the orange cartridge, and Hugo will tell us about his game Tristam Island. As you probably know from the previous event, then I will then restart recording these talks. So of course, if someone does not agree to be recorded, then they should leave the call. You can still follow it on the Facebook Live then. And at the end of so after the last talk, I will let you know when is the next meeting later on this year. So it's not exactly 35, but usually we have the tendency to take a bit more time than what is initially scheduled. So Javier, if you are ready, then I suggest that you start.
Okay, thank you very much. I'm going to start.
Yes.
Should I press the share screen button to put my presentation?
Yes, absolutely.
Okay.
Yes.
So, I'm going to share the screen. Are you seeing it?
Yes, if you can just stop, no, not stop sharing, but just wait a second. I will then restart the recording. Perfect. There you are.
Okay. Well, thank you very much. It's for me a pleasure to be here, to be invited in this new conference. I developed this Python CVM BBS, which is a work in progress, a little framework made in Python language. And everybody can use it to make BBSs. I am a Commodore enthusiast since 1983. I've been a sysop and co-sysop since 1985. Right now, I'm hosting a BBS using this framework also, and I live in Lima, Peru. So I will start with the presentation. Why doing this again? Well, CVM scene is very strong across the world. We have several communities developing, creating a lot of things, a lot of programs, utilities, tools for a Commodore. And BBSs were and are always cool. Joining to a BBS or running a BBS by yourself. Dedicating a C64 right now, a Commodore 128 or any computer from that era to run a BBS, I believe is very expensive and probably not optimal because you cannot have the benefit of multiple concurrent users with a little effort. We can run on a simple server like a Raspberry Pi. And there are a lot of new Wi-Fi modems that I believe should be enabling a new wave of new Commodore software. And maybe more network games, as really they are not too much. Wi-Fi modems for the Commodore are already available. For example, and becoming very popular. The first one I knew several years ago was this one based on the ESP8266 microcontroller developed by Carlos Santiago and Bo Zimmerman. Later on, like in 2021, probably 2020, the German group sent a new BBS, a new service with a device called the VIC-64 by GMP, Kiwi, Lazy Jones, YPS, and it is a device pictured here that runs at 20K BPS. And this year, weeks ago, it was announced in Argentina, the Turbo 56K by Jorge Castillo. This is a very interesting project, very similar to the VIC-64, because not only they are making in the hardware, but also a service that takes advantage on the speed and some particularities they have discovered to transfer images and files at a very high speeds. And of course, if you don't have a Wi-Fi modem, you can use an emulator like Vice and TCP/SER, and also MiSTer with FPGA that also has a UP9600 emulation. As I told you a couple of minutes ago, I run C64 Wordle, which is a Wordle clone, but runs on a BBS online. I have it developed entirely with Python CBBS framework. It's hosted on a Raspberry Pi. You can find us at this URL, IP address, and this port. And the source code for Wordle also can be available in our GitHub soon. So how to develop your own, how to make your own BBS. First of all, you can go to our GitHub and download all the files that are inside Python CVM petscii BBS. You install Python, you copy the script, execute the provided MySQL commands, which are on the page, and then install the MySQL connector that that's gonna make Python reach your MySQL, and run a script, Python 3 bbs.py, and it will start. I'm going to describe some of the sections. For example, the petscii codes conversion, which are on the file funct.py, which have all the functions there. I'm going to make, I don't know if I can make alt tab here, and no, well, no problem. You have only two files, the funct.py, which has this section. To develop this dictionary, I visited this page, stac64.org, and thanks God they have everything. And I took, for example, this A, which is the capitalized A within the graphics mode, which is a C1. So in my dictionary, I put A is a byte, X, which is the connotation of binary, C1. So, or hexadecimal. So I made this dictionary, so it's already done. You don't have to do it. Then the BBS Pi imports the socket, and here the only thing you have to do is put your host or leave empty for any IP. Put a port that you want to make it run, and the server will be waiting for a connection when you execute it. there are like a simple, very simple main loop, which is waiting for a call. This is running. And each time somebody accesses, it starts a thread, a threaded client. Each threaded client will start a user session. A user session will be like a function within your program, your Python program. For example, this is a user session that I made for Wordle, but it's also inside the bbs.py. And you define the function, and while true, you're going to greet the user. You make another function, do welcome connection. This does login and registers a new user, do login connection, and then sends the user to the main contents, do BBS loop. You can make any function and call it here, which is inside this loop, which is executed each time a new connection, a new user session is created. So some of the functions that you will need when you create a section, a function inside your BBS. For example, if you want to input a line of text, for the username, we have this function already done, which is called input line. The only thing you have to pass is the connection variable, and this will input a line of text. Or if you want to input a password, we have the function input pass, which it will output stars instead of the letters. And if you want to get a single char for one key press, we have the get char function already done. Sending text to the user, we have cursor change. Send cursor is the function, and you input the connection and the thing you want to send. For example, to clear a screen, we have the clear command. We have also home command, blue, red, yellow, any color can be sent through this send cursor change. And if you want to change the cursor position, you have a cursor XY command that will change the cursor position to an X column line Y. And if you want to send a simple message, we have the send line function that will auto-convert what you type in your Python script to the proper petscii equivalent. You can also send petscii graphics using sequential files. For example, this is the website called petscii.chris.hu. I'm going to change my screen to there. Oh, I cannot. I don't know how to reach the, okay. And here. I have this drawing that I made with the edit, but at the end, when you start, make your draw, you have to export it, and you export it as a sequential file. Then I recommend to open an X editor. This is the same file I edited, and normally delete all the leading spaces and the trailing spaces also, to have only the data you want to send to the user. So here, to send the file is very easy. You only have one command, send sequential, and you pass the connection and the file, which is right now in a folder called sequence. So sec logo menu dot sequence, and it will send the colored file to the user. And that's it. Thank you very much. And I'm sharing my Twitter account to stay in touch. I don't know if I took much time that was already provided. I don't know the time I took.
I think you're perfectly with the time. Let me check that. Yes, no, we had counted even more time for you, so that's fine. But now let's see if there are any questions. I see already something in the chat. No, it's just a comment. Awesome, perfect. I don't know. Is there any question for you from the attendees? Let's see, maybe on Facebook. I don't see. I see some comments. People saying good evening, but no specific questions. Maybe I had one then. So you showed this let's say sequential file or whatever, but if you want to configure it, configure something or just create new extra menus and and have some interaction, then you need to do it coding by using the existing functions and creating new functions, right?
Yeah, yeah. I can show you, for example, part of the code as we have time. I'm going to enter to. This is a VBS I made with a. I'm going to edit the. And here, well, it's the same. They are the sections that I was telling you. And for example, in this part, I clear the screen, go to the home, no, which is the topmost in the left. And then the only thing I do is send sequence, and I send the logo menu. There I change the cursor to 10, X10, Y7, and I send line top layer list. And for example, here I execute the query. What I do is I'm gonna go to the section which is the menu. Here, for example, no? I'm drawing the word. I go to clear home. I send the menu. I send portions of lines, and I believe this part is going to be better if I connect through Vice. I'm gonna call. It's calling right now.
And you said it's hosted on a Raspberry Pi.
Yeah.
Right? So okay.
I'm gonna enter here. Oh, right now I already ended the game, so I cannot play the game. But I'm gonna make a new. For example, this cola is a sequential file that is sent at the end.
Okay. Yeah.
So that's it normally. What I do, you paint and then you ask for input, and then you clear the screen and you send new text. It's very, very, very easy to make a VBS with this.
Okay. Do you know of any other VBS currently running or with?
No. Right now, this piece of code is under development. I am sharing what I do in my GitHub page. The only VBS running is the one I made.
Okay.
Which is this.
That you know about. It could be that someone.
Probably, yeah. That's not. That happens on the internet.
Yeah. Okay, good. Okay. I don't see any other question. I would say thanks a lot, Javier. I will.
Thank you, Sebastian.
Stop the recording now. You sure you want to stop recording? Yes. And then if there are more questions that come, maybe people can put them in the chat. Maybe if you stay around, you can answer them. Otherwise, people will maybe contact you. And maybe if someone is using already your software, they can provide you feedback, right? Good. Okay. Thank you. I guess you can stop sharing, and then we go to who's next. Then that should be Will, I guess. And Will, so we go really from one side of the world. We were in Europe, we went to Peru, and now we go to, is it Australia?
That's correct. Yeah, forgive me if I start falling asleep on you. Like, I'll do my best to stay awake. But I guess I can start sharing the screen now, can I?
Indeed, yes, yes.
Okay, just make sure I share the correct screen.
Perfect. And then if you can just wait 1 second, then I will start recording as well. Perfect. The floor is yours, Will.
Okay, can you see the PowerPoint slide in front of you?
Yeah, I see a PowerPoint and I see Z64K.
Okay, excellent. Yes, anyway, yeah, thank you, Sebastian, for inviting me along to this meeting. Yeah, my name's William McCabe. I'm the author of Z64K, which is a Java-based application which emulates the Atari 2600, Commodore 64, Commodore 128, VIC-20, and Spectrum emulators. One of the unique features about Z64K is the Commodore 128 emulation with the DO3 register. It actually emulates a 2 megahertz bit quite well, along with the test bit, which I'll demonstrate a little bit later. It also has very accurate VDC emulation and has a test bench UI, SID player, and assembler. To start off, the requirements for Z64K, first of all, you need to go to the website, which I'll just bring over. And you download version 2 of Z64K. Like, there's a version 1, which is just there for archival reasons. But if you want the latest and greatest features, always download version 2. And I recommend using Java Runtime Environment 8 or better. Well, it needs Java 8 or better, but I recommend using Java 8. Okay, optional. The jar can be just run as an executable, but I do recommend setting up a bat file, or depending what operating system you're using, use that equivalent. So I'll get straight to... Okay, so I'm starting fresh with a brand new install. I've already created the batch file. So I'm just going to start up and guide you through how you should initially set up Z64K. So once you load up, you're presented with a portal page, which you can choose which application you want to start. The first thing you'll want to do is actually go to Applications, Machine Monitor. And if you see this kind of mess here with the graphics, you'll need to go to Settings, Machine Settings, General, and enable OpenGL. Save it, exit, and that'll create the config file, which will save that setting for future use. So you only need to do that once. And that's usually required for newer systems. Older systems, you shouldn't need to do that. So I'm going to start up again. And the next step you want to do is actually set up the configuration. So Settings, Machine Settings, and we'll go to Global Settings. So a lot of these should be self-explanatory. At the moment, I'm on display 1. So this is for the full screen setup. I usually like to keep the aspect ratio. So when you go full screen, you keep the aspect ratio intact. Of course, if you unselect keep aspect ratio, it's going to use the entire screen. Going straight to the next setting, like you've already seen this settings here where we enabled OpenGL. Just to confirm, the graphics are now fixed. You see there's no glitches now when I step through the cycles in the monitor. And I will come back to the monitor with some of the features with that. But for now, we're just working on getting the application set up. If you want to start the jar file in another, by defaulting to Commodore 128, Commodore 64, you can select that here as well, but I'll just keep it to Portal at this stage. And there's some other settings here you can tweak depending on what your system can handle. Okay, JInput is the next thing you might want to install if you have any gamepads for games. So if I go to controllers, at the moment you see gamepad is disabled. I do have a gamepad actually plugged into my machine at the moment. So you only need to do this once as well, install JInput. And all that does is install a library file here. So your operating system can actually knows how to communicate with your gamepad. Okay, moving right along. Keyboard mapping. This is going to be important if you're not using a US keyboard, like if you've got a German keyboard or some other keyboard, you can actually map your keys to match your keyboard here. So for example, if I select G, you'll see in the top corner here, an ID here. That's the Commodore 64 ID, which is KB_G, which is a Commodore 64 G, and is currently assigned the PCG. For example, I'm just going to assign that to W now, and you'll see that key's assigned W now. So if I push G on the keyboard, it's going to output W's. Because I changed the key mapping for W, W actually gets G now. So if I push G, or if I push W, it's outputting G's now. I'm going to set it back to the default. Like that's just an example like of how you do assign keys. Once you're happy with your keyboard mapping and you've assigned all your keys, you can save. And in the config, you'll notice there's a new folder here, keyboard, and the keyboard mapping file will be saved depending on your current keyboard, your system's keyboard mapping. Okay, language is self-explanatory. You just choose whatever language here. Like when Z64K loads up, it should automatically detect your language if available. Okay, media. This is for screenshots. I might actually go to the Commodore 128 emulation to demonstrate this. And go to the AT screen mode. So back to media. At the moment, I've got 1 by 1 pixels. So if I save a screenshot, 1 by 1, save. I'm going to save the 4 by 3 now, or that's using X as a reference point. X, save. And finally, Y. Screenshot. Y, save. So I'll show the difference with the output of those. So if I look at the properties of the original one, you notice the dimensions are 800 by 285, which is all the pixels that you see on the screen. Like if I open that up, you'll see it's actually stretched quite a bit. It's not keeping the aspect ratio when it saves. These other two do keep the aspect ratio. And for the X, it retains the X dimension, but it will increase the height to match the aspect ratio, or to keep the aspect ratio. And for the Y, the same thing, except for the Y this time. Properties, details. The height is the same as the 1 by 1 pixels, but the X is adjusted to keep the aspect ratio. And test bench, that's used just for internal testing, so I won't go through that at the moment. The next thing you want to set up, or probably want to set up, is the paths. So I'll just quickly go through this and set all this up. So program. The cartridge is used by both the Commodore 64 and the Commodore 128. All the others can be separate values. And the cartridge. And I'll also do the Commodore 128. And save. Okay, next thing, if you've got custom ROMs like Jiffy DOS, this is where you can set that up. First of all, you need to give the ROM set a name. Then you can start assigning the ROMs for the different emulators. So I'll just assign C64, C128, sorry. Won't worry about the VIC-20. And make sure you save, and then you'll see Jiffy DOS appear here. And those ROMs will be available immediately. So if you go to ROM here, ROM set, you can select Jiffy DOS, and for each of the ones that are populated, will automatically populate the device that ROM is actually for. So if I do a reset now, you'll see now that it's actually indeed using the Jiffy DOS ROM. The final bit of configuration, depending what your system you got, you might want to increase the buffer size for your sound if you're hearing like stutters with your sound. But for now, I'll just keep everything as default. Okay, the final bit of setup you might want to do before you start using the emulation is go to applications. Test bench is actually used just for internal testing, but if you want to play with that yourself, it's I'll just bring up the other slide. You can get the test programs from the Vice test repository, and that's the link there. So I've already downloaded all those files, so I'll go to configuration and go to the location I've saved that locally. Need to go to test programs and the folder called test bench within that test program folder. Open, and if everything goes all right, the status will change to installed, and you'll notice that you've got the tree structure here with all the tests that you can run on your emulation. It does support other emulators as well, test bench, for, as you can see there. But, yeah, I won't go into much detail there, being mindful of time. And for now, I'll just exit. And the final one to set up now is for SID player. So I've already downloaded the latest high voltage SID collection from the following website. So I'll configure to point to where I've downloaded it locally. C64 music. And once again, the status will stay installed if installed correctly, and exit. There are other settings you can change depending what you like. If you want to start with 8580 emulation instead of 6581, you can select it here. Your VIC type, CIO type, and a whole other features. But for now, I'm going to close the emulator to make sure all those settings have applied. And we'll restart now. Yeah, one thing I will say, like with these machine model settings, these will, you can do a hot switch of the different standards. So like NTSC, you don't need to do a reset. It will actually swap straight away. Same with power, with your SID emulation. So everything can be hot switched here. All right. All right, I'm going to go to the Commodore 128 emulation now and just show some of the features that are unique to Z64K. If I set Z64K to fast mode, made the C128 emulation to fast mode, 6,1, you'll actually see garbage on the screen exactly like it does on real hardware there. So I'm going to open up Test Bench just to quickly open up one of the test programs I actually contributed, which is called DO3 Tester, which is available on the test repository site, which I gave the link before. What this program does, it actually tests the DO3 register, and you can do some pretty funky things with the DO3 register, like actually move the Commodore 64 screen up and down. Like this is only in Commodore 128 emulation, and this is being tested on real hardware for this behavior as well. This text here is actually in 2 megahertz mode as well. So that won't display unless the DO3 register is actually implemented. Down the bottom here, this is the test bit, the test register test and DO3O. And you'll notice that you've got additional colors down here. So that's like the real hardware as well. There's a demo I'm going to show shortly that actually exploits this feature. I'm sure most people know about it, risen from oblivion from Crest. I think I might be going a bit over time, so I'll make this quick. So I'm just going to fast forward this now. So all these features you see require actually the DO3 register to actually work. So all these tricks are actually relying on what the 2 megahertz mode puts on the bus. Just quickly skip past this. Now, one of the things you can do to actually speed things up as well, you can disable the sound chip here, which will, when you're in fast mode, speed things up. So I'm in warp mode at the moment. I'm just trying to skip past as much as I can to get to a trick that actually uses the DO3 test bit. So you'll notice there's one little glitch here, which I'm still working on fixing, but pretty much the DO3O register is completely implemented. And the final trick. Yeah, you notice this demo actually uses the full screen, and you'll notice there's actually a color switch with the bottom image down here. That's caused by the DO3 register as well. There is it. All right, I've got better move right along. All right, the next feature I want to go about quickly is some of the features with the machine monitor. For this, I'm actually going to start this in the command prompt. So command prompt will always overwrite what you have in your settings. So how I'm starting the emulation is using Z64K BAT, starting in C64 mode. I'm actually starting with mon commands here. If I can open up the mon command. I don't know if you can read that, but like what's contained in that mon command is add a label at DE00 called IO test. It's going to set a breakpoint at DE00 and then exit. And what this test program is going to be running in the IO range. So I'll start it. And it's set a breakpoint, it's triggered a breakpoint. And what I'm demonstrating here is on the bus, like the disassembly window will actually update depending what's on the bus. So at the moment you see load Y AC01. So it hasn't actually retrieved the correct value from the bus yet. So if I do a single step, it's got the value off the bus and it's dynamically updated that disassembly to the correct value. So as you can see, it can single cycle step through using the disassembly window. If you push help, you can see a lot of the commands there. So I won't go to them in detail. I've been trying to be mindful of time. I think I'm going way over. And exit out of that. Okay. All right. Next thing I want to quickly demonstrate. I won't have time to go through all this. Yeah, some of the more the settings, like you've got your cartridge ports here. So I'm going to demonstrate. Oh, actually, I don't have time to demonstrate that now. What I did want to demonstrate is the user port. Like you've got the RS-232 emulation. So for the TCP servers out there, like you can connect via putting using this address here, but disable internal modem if you want to connect to an external modem. But for now, I'm going to use the internal modem here. So what I'm using here is Retro BBS. Retro BBS and Retro Term version 3.01. So you can like download your own from there. Like I've got a local version of the BBS on my system, which I'm quickly going to demonstrate. Just going to enable echo there as well. Yep, so that's just your standard BBS you can connect to. So I won't go through too much through that. Exit. Yeah, Sebastian, how am I going for time? I'm being mindful. I'm probably gone way over.
Yes, you're a bit over. That I mean, that's not an issue. You know, it's a meeting for passionate people and by passionate people. So that's perfectly fine. I mean.
Yeah. Okay. Then, like, yeah, because I think I've got a lot more material than I realised how long it was going to take. But I'll persevere. I'm just rushing things now. So. Yeah, actually, I might finish up there, like just because I'm going way over. So I might open up to questions if anybody's got questions on.
I've seen some things passing by. Let me see. Okay, Eduardo says I didn't have enough time to get the whole Java download path. Okay, maybe please share if time allows. Maybe what you can do, Will, is after is if you can copy all these links into the chat.
Yeah, I'll do that. Yes.
Then we have them there, and then I can also share that on the page, on the Commodore user web page, when probably in the coming days when I will post the link to the video as well.
Yeah.
Then it says, how about Commodore graphics keys? Z64K has graphics key possibility on keyboard mapping. I think you showed that, right?
I did. I'll just bring that back up again. Hang on, have I still got it open?
Support for paddles as well. You showed, you demonstrated how we could actually configure and adding a gamepad. Gamepad meaning paddle, if I'm correct.
Yeah, that's correct. So like just a joystick. So
yeah.
Hang on, where's mine? So that's what I'm using connected to my computer. So if you've got one of those connected, yeah, you can use it to play games. So yeah, here's your keyboard mapping. So yeah, like you got your Commodore key there, you can map as well. Like, yeah, I've had a lot of requests how to map keyboards over time. So this is pretty much where you do it at.
Yeah. I think you're also referring to these graphics keys, that you get on the side of the keyboard. You know, these.
like if you push control, like
yes,
is this
exactly.
Yes, yeah. So yeah, so yeah, on the real Commodore 64, of course, you push the Commodore key for that, or you've got you can change colors as well. So you get the hint from actually going to this keyboard. So here I've got the Commodore key assigned to the control key. So if I wanted the special characters, I'll push control and then the key with that special graphic on it.
Mm-hmm. Looks nice.
I did want to show just one last thing that I think is unique to Z64K. If I go to the model, there's a drive GPU here. What I'm going to load up is a program called FreeSpin. Which I've got the link for that here as well. So I don't know if people remember seeing this demo late last year, but what this is, it's a demo that just runs completely off the disk drive. Like you use the computer to actually load the program onto the drive. And once it's actually loaded, you can actually disconnect the computer. So I've disconnected the computer there. And to get the demo started, load drive 8 again and just reload the same disk again. So this particular program runs completely off the disk drive. So you can follow that link, which I'll send later, which shows how that actually all works as well. But yep, on that note, I'll leave that there. And yep, I'll just leave it open to questions and I can finish my presentation if you're happy with that.
Yeah, I have actually a couple of questions. So now we saw that it was running on Java runtime version 8, but you're demonstrating this on Windows. But so I suppose it's really just it's not system dependent. It's Java runtime dependent, right?
That's correct. I've had it running on a Raspberry Pi. Of course, it doesn't run full speed on a Raspberry Pi because it actually does need quite a well-spec'd computer to run on, but I have run it in Linux and I know people have run it on Macs as well with no problems.
Okay, and it's quite the configuration. If I followed correctly at the beginning, so it's quite modular, right? So you can actually import what you want, like you showed the example of this of the gamepad. So by default, it doesn't come with it's not configured to handle the gamepad, but then you go into the configuration, you select, and then it's this additional module is installing.
Yeah.
Okay, and you had then different version there, 64, 128, but I saw VIC-20 as well.
Yes, we've got VIC-20.
Perfect. Okay.
So yeah, the reason for creating the VIC-20 was for the VIA emulation, like because it's got quite a few good test programs there. People have asked me why the Atari 2600 as well. It was a system that actually uses the ready pin of the 6502, which helped with that, like with the VIC ready signal, and also the ZX Spectrum. What is ZX Spectrum? Z80 emulation. So the Z80 emulation is pretty much 100% accurate on the Commodore 128. It passes ZEX all in addition to ZEX doc, if people know what those particular programs are. And they all should be cycle exact all the commands as well for the Z80. And one of the bit of a connection with the Commodore 64 with the ZX Spectrum emulator, if I go to settings, you can actually have a SID on the ZX Spectrum as well.
Okay. Today we skip to we stick to Commodore.
Yeah. Like I thought so. That's why I was leaving those ones around.
No. That's why I was referring to the VIC-20. Actually, I have interest in that one as well.
Yeah. So the VIC-20 NTSC also has interlace emulation implemented as well. So some of the demos by Tokra will actually work in NTSC on the VIC-20. So yeah, something worth checking out as well.
And I saw you started working on that in 2014. I saw somewhere you had 2014, 2021.
Yeah, that's correct. Started in 2014. The whole purpose was initially to start teaching myself Java, and the project just started getting bigger than like I originally planned, and that's where it is today. Like it's always like once you kind of start studying one thing, that leads on to something else, and yeah, it's been a great project, and it's been a great collaboration with the community as well. A lot of the features have been in collaboration with the community with feature requests. So if you got any feature requests, yeah, please reach out.
Good to know. Okay, perfect. Thanks a lot, Will. I see nice comment. People making a thumbs up and impressive, cool, nice, perfect. So I will then stop the recording now. Thanks a lot again. Yeah. If you can then post the link somewhere.
Yep, I'll do that.
And then I don't know if you stay around, then maybe more questions will come up. I don't know.
Yep, I'll hang around if there's any more questions. So, yep.
Thanks a lot for that. So I stop the recording. And we should have Chiron still in the call, I hope.
Hello, can you hear me?
Yes, I can hear you. I can see you.
Okay, great. Let me just.
So Will, if you can stop sharing, so that.
All right, where do I stop? Oh, yeah, I see.
Thank you.
There we go.
Perfect. And then Chiron, I don't know if you start sharing something or if you start with just talking. I don't know. Just let me know.
Yeah, I'll start talking and then I'll switch to screen sharing.
Okay. I started the recording, so please, the floor is yours.
Okay, great. Well, thank you for having me. So a couple of years ago, I found myself using my Commodore 64, and I'm not someone who memorized all the Jiffy DOS shortcuts and commands, and I wanted to explore some of the advanced features of the SD2IC. And I was constantly looking up the different DOS codes and commands and all the syntax for that. And I thought, okay, you know what? I'm just gonna make a little program to make those things a little easier. And that's kind of where this started. And it just kind of got out of control, I guess. So what it evolved into was, after some enthusiasm from the community and sharing it with the Toronto Pet Users Group in Toronto, Canada, I decided, okay, I'm gonna try to make this the best, most polished, usable. I can share this with people and feel good about it as I possibly can. Make my best effort to do that. So and basically what this is like, it's inspired by, let's say, Amiga DOS, MS-DOS, Linux terminal, and it's a command line interface for the Commodore 64. So my name is Chiron Bramberger, and I named it chiCLI, and I'm going to turn on screen sharing, and we'll take a quick tour. Okay, so does everybody see my desktop?
I can see it.
Okay, great. So this is the GitHub page for it, and we will minimize that for now. And I'm going to go ahead and drag the chiCLI disk into Vice. I'm using Vice to ensure that this demo goes smoothly, because right beside me is a 40-year-old Commodore 64, but I wanted to make sure that that everything went smoothly. So, Okay, so here we are. This is how it boots up. And I'm just going to run the sysinfo command, which is what it runs on startup, just so that you can see it one more time in full screen. So here we go. This is what it looks like when you first start the program. And there you go. So I tried my very best to recreate the chirp from the Commodore PET. So some of you might recognize that. You can even type in the chirp command if you want to hear it again. So what we've got now is a couple things. Hopefully you can see my mouse pointer here, but basically this is like NeoFetch on Linux. It's trying to detect hardware. Now I only officially support machines as they would have come from Commodore, and I try to support beyond that as best as I can, but this is not intended to be like a robust, super duper hardware troubleshooting diagnostic type of thing. It just tries to identify your machine and show it. So at the top, it's identified that this is a Commodore 64C, but it's also identified that it's running in Vice. And it's detected that it's running in NTSC. It's detected that there's Jiffy DOS, but it's the R3 kernel. And again, when you're running a C64C, you have the MOS 8500 CPU. It's running at 1.02 megahertz, and that is detected. I can talk about that later. And the graphics processor there, that's the right one for the Commodore 64C. And there's our SID detection. Of this, the SID detection is using the best method for looking at a Commodore SID chip and determining if it's the 6581 or the 8580. If that is the basis for a lot of the hardware detection. So at the moment, if you have a non-standard system, or if you're using ARM SID or Swin SID or something, it may not totally detect what model of Commodore 64 it is. And if that's the case, it's just going to say, okay, it's a Commodore 64 and it's a MOS CPU and it's using a VIC-2, but it won't have more detailed information. Now, just to be clear, I've written this in the C programming language using the CC65 emulator, and I've done that for two reasons. A, because it's harder. So specifically, you can program in BASIC and you can program in assembler, and you can do great things in assembler and you can do fast things in BASIC, but doing things in C is tougher than assembler in some ways, because even though some people might think that programming in C is easier, programming in assembler lets you get down to the hardware level. I wanted to do my best to develop my skills at interfacing with the Commodore 64 through C at that hardware level. In addition to that, I also wanted it to make me a better C programmer. So that's what the motivation is. Having said that, in the future, I'd like to improve the hardware detection. I'd like to directly detect the VIC instead of basing it on the SID and then assuming that the machine is either a 64 or 64C, for example. I want to directly detect the hardware chip. I found assembler code to do that. I just haven't implemented it in C. And I'll talk more about that later. But the short story is every version of this program that I release is completely full, meaning it fills up all available or nearly all the available memory on a Commodore 64. So every time I've added a new command or a new function or a new feature or a new hardware support, I go over the 64K, or it's about 52K that you can get away with. And so I have to go and optimize the program. So that has also made me a better C programmer, hopefully. And that's part of the process. So that's why there are a lot of features that are implemented the way they are, or things that I haven't implemented or haven't refined. For example, like really great error messages, because it would just take up too much room and I'm always running out of room. So anyway, here we go. So again, the system info command goes through when you first start it or when you run it, and it goes through the devices and it detects what devices you have. Here we have device 8 is Jiffy DOS and a 1541, and then this is device 9. This is a CMD hard drive running DOS here. I picked these two devices because CMD hard drive, like the CMD HD, is what the SD to IEC was modeled on. And so it's the best way to emulate having an SD to IEC in device. So the first thing I'll show you is the help command. And when you run the help command, it displays some help. And one of the things it shows you is that you can type in help commands to get a list of commands that you can then search for help on. And so here's our command list. So I'm going to go through it very quickly, and then I'll show you some of the essential commands. But basically, we've got 1571. That allows you to put the 1571 drive into double-sided or single-sided mode. The // is a little complicated. I'm going to leave that for later, but basically it lets you run a program from within chiCLI, but you can also send it command line parameters. And that's part of the feature of CC65 is you can launch a program either from BASIC or from another program and send them command line arguments. But that's a little bit, that's a rabbit hole we'll go down later. The @ command here, this is very much, it's a shortcut, not entirely, but basically a shortcut for the DOS command. So the DOS command lets you run a specific DOS command if you want to send a DOS command to a device. So for example, if you wanted to send the DOS command V, that would run validate. So that's how you would use the DOS command to do that. I created this shortcut for people who are used to Jiffy DOS shortcuts so that they can send something like this instead. That's all. So it's a shortcut for the DOS command, but it works a little bit differently because of that. The equals command, that's basically a quick little math command. About tells you more about the program. Alias, the system has aliases defined, and I'll show you that in a moment, but it's similar to Linux or Amiga-DOS. The cd command changes directory. Chirp, you saw, makes the little noise. Clear, well, that clears the screen. Color set, it lets you pick the specific colors you want for the display. Convert is a number conversion thing. So if you're peeking and poking in memory, this will let you convert between decimal and hex and show something in binary, things like that. The copy command, it copies files. The date, time, and time command all display the date if you have a real-time clock. So for example, the command HD does have a real-time clock. Some SD to IECs have a real-time clock. I actually bought the chip and the oscillator for mine and installed it, and so I have that on mine as well. I'll show you that. The delete command deletes a file. Disk copy, that's for dual drives like the Commodore 4040 or the super disk drive MSD SD2 drive. I have one sitting here. It'll copy directly from one drive to another within the same device. So this just is a shortcut for that. The DOS command I show you lets you send any DOS command you want to the device. Drive detect runs the drive detect is the same command or the same function as when you run sysinfo and it detects all the drives. So this is just that as a command. Drive set lets you change the device number of a device that you're using or drive. So if you wanted to make your SD2IC respond to device 11 temporarily, you can use drive set to do that. It's more of a temporary stopgap. Some of the way that the program works right now is once you change the device number of a device, it can't detect the drives anymore because it doesn't know what's assigned to what. So it's sort of like, okay, you temporarily change the device name, you do what you need to do, then go and restart the program and back to business as usual. But it's a convenience. Dump mem, there's actually a view mem command and a dump mem command that allows you to look at memory. The dump mem command allows you to save that to a file. So if you just want to save a block of memory to a file, it'll do that. Or you could even save the kernel ROM. The echo command is exactly what you would expect it to be, just echoes text. Exit gets out of the program. File date shows you the date of files when they're supported by the device, like the SD2IC. Format's a floppy disk. Help, you saw. Hotkey is for assigning things to the function keys on the Commodore 64. ID64 is a hardware command. It lets you turn on or off write protect if you have an ID64. The init command sends the initialize command to the device. Key codes lets you see what keys you type in, and it shows you the key code. I'll show you that. LD and its alias LP are for list drives or list partitions, and it shows you the partitions on a device. So for example, Command HD and SD2IC have partitions, and this lists them so you can change them. The list command is like the directory command. Directory is actually a short form for list, but it displays it a little differently. I'll show you that in a moment. Make directory makes a directory. Mount is if you're using the SD2IC, you can mount a disk image that way. And I'll show you how you can extract files from a disk image. Well, we'll see what we have time for. But if you have an SD2IC and your SD card has two partitions on it, you can use one partition, mount a disk image, and then using my program, copy those files to the second partition on the same SD card. The part command is just another way to change partitions, and I'll show you how the CD command and the partition command allow you to navigate your different drives and partitions. Peek is like peek. Peeking does it over and over and over again if you want to look at changing hardware values. Poke is similar to the DOS basic poke command, but this isn't trying to replace basic or Jiffy DOS or anything like that. So it works without a comma, but other than that, it's a poke command. Profile loads a color profile. PWD, that prints the working drive and directory. Reboot reboots your machine. Relabel changes the name of a disk. So if you have 1541, you put a disk in, you want to change the label and the ID number, or not number, but the ID code. Relabel does that. Rename renames files. Remove directory removes an empty directory. Run runs a program. SD2IC allows you to change certain settings, so you can change whether or not the SD2IC shows extensions or hides them. And if you change your drive number with drive set or DRV set, then you can save that as a permanent drive letter change using the SD2IC command. Shuts down your machine. I'll show you that. It's pretty cute. The speed command is what actually is run when you start up and you run sysinfo, and it shows you the speed in megahertz. It actually does execute a no-op payload and attempt to time how long that takes. And so it is real. It's not just, oh, everything's just outputting the correct text and because I know it ahead of time. It's not a perfect benchmarking, and it's not intended to be. So what I do is when the math is kind of on the edge, I take a range of values and go, okay, it's probably this speed or that speed. So for the common speeds of common machines like Super CPU or Commodore 64 or Commodore 128, it will output the speed that it's supposed to be if the results are, within one or two values of the range that they should be for that. If you're running, let's say, an Ultimate 64, I believe it will show you the different speeds, because there's like 5 or 6 different speeds that the Ultimate can run at. So it's real, but it's not, a benchmark, and you shouldn't use it as such. SS is for screensaver. It shows a little logo with the time or the CPU temperature. That's right, we're getting there. Status gives you the drive status. Stopwatch, I have that assigned to a function key, but basically you run it once, it starts a stopwatch. You stop the stopwatch by running it again, and it tells you how long it's been. I think it has a few hours that it'll go. I forget what the limit is. It's in the help file. Super CPU, that allows you to actually turn on or off the super CPU acceleration if you have a super CPU. The sys command is like the basic sys command. It allows you to jump to a point in memory and start executing. Not super useful, but can be somewhat useful. But most of the time, it's going to screw up the fact that chiCLI is loaded and running and doesn't expect you to go willy-nilly in memory and start executing stuff. But for example, if there are some situations where that's useful, probably more of a debugging tool. Sysinfo you saw. Temperature, I'll show this at the very end, but this displays the CPU temperature. That's right, no extra hardware, no nothing. It'll figure it out. Time, again, shows the time if you have a real-time clock. The type command is like in DOS. It types a text file, and I'll show you that. The help command is also just typing text files. So it's similar to the type command, but the type command will also display things in hex. And if you have a basic program, it'll actually read the basic program and reinterpret and output the basic text. So it'll look up the basic tokens and actually output the text for that. Unalias allows you to unassign an alias. Unmount lets you unmount a disk image. Validate sends a DOS validate command. And viewmem, like I said, lets you poke around memory and view it in like a hexadecimal table. So what should we start with? Well, the first thing you can start is, so you start the program, you get this neat little screen, it's fun. And then you go, let's say, instead of list, I've got many common shortcuts, so I'll go ls. And now we're looking at the files on the chiCLI distribution disk. Now, if I type in ls/l for long, it'll give me this output, or s for short will give me the short version. Directory is basically a shortcut to that. So typing directory, and that's a 2-column view. It doesn't show you the file sizes, but it takes up less screen room, so that can be helpful. Now, if you want to change devices or directory, you can go cd. Now, if you remember from the opening screen, I had another device set up. So similar to the Amiga, this is how you can change to a different device. But instead of df0, we're going device d09 and then colon, and now you're on that one. So this is our CMD hard drive. So what I can do now is, and again, there are aliases and shortcuts for common commands. So instead of make dir, I can actually just go md. And let's say I'm going to do this. So I'm going to go like that. And now you can see I've created that directory. Now, if I go cd chiCLI disk, now I'm in that directory. Great. So if I want to copy some files, I can then go back to drive 8, which is our 1541. And I can, well, actually here, if I look at the sizes, I don't want to waste your time. So what I'm going to do is I'm just going to copy chiCLI help, and I'm going to use this command here. So that's autocomplete. So if you type in control and the left arrow on the Commodore keyboard, that does an autocomplete, and it's gone through our directory listing and found the first match. So now I don't have to type the rest of that file in. And if I want to copy that, I can just do this. It's going to go to the directory that we were last in, similar to the way MS-DOS works. So if I go like that, it's going to detect the file. It's going to copy it. It's only 1K in size, so it's pretty fast. And now when we go back there, that was a typo, but I actually correct for several typos because the Commodore 64 keyboard doesn't do anti-ghosting or NQ rollover. So some of the very common typos, if you see them go by and it still works, it's because I automatically correct for them. But here we go. There's our sequential file. So I could also, if I wanted to, go back here and see, instead of CD, I just typed in C, because if you press C and hold it down and press D, it won't register that. So that's the only shortcut that's a 1-letter shortcut for the CD command. But anyway, I can go copy star, so everything, and I can now copy that to the other drive. And it'll say, are you sure you're going to copy 9 files? And I can go, okay. Now, this is going to take a long time. So I'm actually going to press Control C or run stop, and it's going to get out of there because I don't want to waste your time, watching this thing copy files for a few minutes. So there we go. Now, if I go to the next drive and I go, okay, great, I've copied a file, but you know what? This program file, I know it's 5K, but I know the original file, is 48K. Oh, right, because I stopped copying. Let's go ahead and, well, why don't we rename it? And ren is a shortcut for rename. There you go. So I'm going to rename chiCLI. And in fact, let's use that autocomplete. So if I go C, oh, it's picked the first one, so I can just back up and do that. All right, so I'll just do that. But again, we've got that. I'm going to rename chiCLI to chiCLI and incomplete. I see. Sure. So when I list it, I've changed the file name. And again, this is all about taking advantage of muscle memory. So I'm used to Amiga DOS or MS-DOS or even Linux terminal commands and things. And I wanted something that was easy to remember than Jiffy DOS. So this isn't, you know, my attempt to create a whole operating system or to replace Jiffy DOS. It's a terminal. It's a command line interface. So I'm going to go ahead and delete it. That's great. Now let's say I just want to delete everything. I can actually go delete star, and it'll do that as well. So there we go. Now, if I want to list partitions, I can do that. And it's going to go and it's going to show me the two different partitions here. So in this case, because I'm in the folder chiCLI.disk, it's listing that as the disk name. But you can see here, if I actually go back, now I'm in the root folder. And if I go list partitions again, it's going to give me the name of the current folder, which is the partition name in this case. So if I want to switch to a partition, I can do it a few ways. I can go like this, and then I can go partition A, and now I'm in partition A. Great. But let's say I want to go to partition B, I can go like this, and now I'm in partition B. And if I wanted, there's nothing in there for now, but here, why don't I make a directory, and I can go, this is part B. And then when we do a list, we can see, okay, great, we're in part B. Now, if I want to quickly switch to partition A, I created a shortcut command for that, which I like. So there it is. So I can go partition B, and I can go back partition A. Now, if I want to change devices again, I can go to device there like that. Whoops, whatever, it worked. And I can also directly type in just this, and it will go directly there. So if you don't want to bother typing in CD for changing devices, you can skip that. But I obviously can't just type in chiCLI disk because that's a folder. I actually have to go into the folder. So if you press up, there is a command history. It goes back about 5. 5 is a good balance between gobbling up memory, which is measured in individual characters and bytes. And I found that 5 was extremely useful. So I can go back and I can grab a previously entered command. So let's say I do the validate command. Are you sure? Yes. All right. So now it's processing the validate command. I'll do it one more time. I'll press up, right? Because I can go through my command history. So press up. Are you sure? And you can see there's some drive activity down here. So that's run the validate command. If I go init, it's going to do the same thing, and it's going to do that. Now, if I love Jiffy DOS and I love the shortcut, here, I'll just do this again so you can see this. I'll use this Jiffy DOS shortcut, and I'll go V, and it's going to run it right away. It's not going to ask any questions. So that's one of the differences. So there you go. So that is that command. Now, if you want to change devices without typing something in and use the Jiffy DOS shortcut Control D, that will do it. So here we are, device 8, Control D cycles to device 9, Control D cycles back to device 8. So that's a shortcut that's friendly for people who like Jiffy DOS and sort of have that muscle memory going. Let's see here. Now, I'm not going to show each and every command because that would make this very long, but the idea is that you can do all of the file management stuff that you would do on more modern systems, and it's more comfortable to do so. So you can copy files, delete files, make directories, rename directories, copy files from different devices, stuff like that. So let's show some of the other things here. If I show alias, this is a list of aliases. So for example, if I wanted to set my own alias, let's see here, how many slots? I've got 8 slots and there's 1 free at the moment. I can clear all those slots, but these are the default ones. So I could go, let's say alias, and we'll go hello. And then I can do this. I can go echo, hey. And now when I type in hello, it does that. And there you can see at the end, there's the aliases. Now, hotkey. So hotkeys, just a short form for hotkey. So hotkeys shows you the available hotkeys, and this shows me the various features. If I press, for example, function 5, it starts the stopwatch. If I press it again, it stops the stopwatch and it shows me it's been 3.2 seconds since I did that. Likewise, if I hit F3, I can clear the screen. If I hit F1, I can do a list. If I hit F6, it's going to run system info again. And if I hit F8, it's going to show me that help file again. Now, the help system is dependent on having these help files right here in the folder that you're currently in. So if you go to another device and those help files aren't there, it's not going to work. You'll have to go back to the device and do it that way. This is because I want people to be able to copy just the program to a disk or a cartridge or whatever and use it without worrying about having all the all the files and whatnot if you're memory constrained or whatever. I'm also working on a printed manual, and I can talk about that later, but the idea would be that you could have a nice printed manual on your desk, and that would help you use it. So let's see what else I can show here that's fun and exciting. So the date command shows the date, the time shows the time, and date time shows the date and the time. If I run the screensaver, by default, it shows the date and time as it's being pulled from the RTC on the systems that support it. Now, actually, I can use the shortcut. What else can we show everyone here? Let's see. Showed you the delete command. Basically, the DOS command just lets me send, for example, the validate command, and that should work unless I've got that wrong. Maybe that's a little, oh, validate, that's going to take a while. Sorry about that. Let's go to warp mode, wait for it to be finished. Maybe I got that wrong. Good news, I can just restart it, hence why I'm using Vice. My apologies. But whatever you enter into the DOS command, it'll just send it to the device once it checks that you're sure you want to do that. So you have to know what you're sending. So if I go drive detect, it's going to detect the current drive. Let's see.
Is one question available?
Hello?
Can you show type with a text document? Have you a text document there?
Yes. So I will list some of the files here. So there's a README file. So if I go type chiCLI, use autocomplete, README, and now it's printing out the content of the text file. Now, if I do help for type, there are some options. So one of the things I can do is H, and that's going to give me a hexadecimal view of the file we just saw. And so now you can see we've got the hex and the character numbers here, and then here's the content we just saw. And if I had a basic program, I could show that. So if I do this, now this is a machine language program, but you can see if we were to list this in BASIC, that's what we would see is 800 sys 2061. And it also shows the header and the footer codes of the BASIC file. And let's see. So what else can we show here? Oh, yeah, file date. So if you have an SD2IC or command HD, I can go file date and it'll, oh, right, because this is different. I think I need to do, let's see here. Oh, right. Okay, I can show this. Sorry, the 1541 doesn't support file dates, obviously, so that's why that didn't work. But what I can do is to show you the output of that, I'm going to copy chiCLI, just the help file, just one of the small ones, to here. It's going to copy the file. I'll do the Command D, switch to the device, list it. Now, if I go file date and autocomplete, it shows that that's the day and the time that the file was created. So that's pretty fun. And let's see, what else can I show you?
This is all very cool. Can we look at temp real quick?
Not yet. No, we're not done.
Okay.
Saving that till the end. But thank you. I appreciate the enthusiasm. So key codes, that just shows me the key codes when I type things. That's exciting. It's good for development. We saw a lot of this stuff. If you want to peek, you can do a peek, but peeking, actually, here's what I can do. I can go like this. And then peeking runs over and over and over again. In this case, this is color RAM, and these are the unused color RAM lines. So that's kind of the exciting part for that. So if you're poking around in memory and you want to see a changing value, that's what that's useful for. This shows you we're on device 8. We're on the first partition. It's only got one, and that's the name of the disk. If we do list partitions, we can see there's only one, and we can see the disk name here and then the number, but I can go relabel, and I could go, I could call this test and TC, TS, TT, there we go. Are you sure? Yes. So it's relabeled the disk. If I do a list, you'll see it's now called test. And if I go list partitions or list drives, you'll see it shows test and TT. And if I want to change it back, I can do this. And then we'll see that it is back to the way it was. Great. And what else? The run command, you just type in like run chiCLI, but there's also help. If I load the help for that, if you have Turbo Macro Pro, it will actually load Turbo Macro Pro and then run the system command to run it from memory. So for example, you could type, I don't have Turbo Macro Pro in this disk image right now, but run Turbo Macro Pro, if that's the name of the file, or if it's just TM or whatever, TMB or P or TMP, I think is what it's usually called. You go run, TMP and then /T, and it automatically uses this to run it. So that's a nice shortcut for Turbo Macro Pro users. The speed command spits that out. And I think the view mem allows you to view memory. It starts at the beginning of memory, but you can also start somewhere else. And if you want to dump memory, you can, and then you can specify, where in memory you want it to start or stop. Or I have a shortcut, so you can go ROM kernel, and it'll dump the kernel to a file. I'm not going to bother that because it'll take a while. So finally, if I run the temperature command, now this is an emulator, so it's only going to show 41 degrees Celsius, because what Vice does is it uses what I think is the common value that's output from a Commodore 64 that has a heat shield, because I've noticed that if you let it run for a little while with the heat shield on, that tends to be the temperature. So I'm sure the big question now is, well, wait a minute, how is it measuring the temperature? So I'm not the first person to think of this, but I couldn't find anywhere any programs online that did it. I'm sure it's got to exist, but I wanted to do it myself. So what happens is there are some unused pins on the Commodore 64. Let's see if I can show you here. This might help. I don't know if we can focus. Here, let's see if I can just, where is it? Stop screen sharing. Okay, so if you can see me, I'm going to show you some schematics. So right about here, so this is the 6502 on the Commodore 64, 6510, sorry. and it's got these P3, P4, P5 pins, and they're used for the cassette motor stuff. Well, that register in memory has some unused pins. And the thing with those unused pins is they're not connected to the package at all, but they do exist on the die. So if you turn a pin on, if you set the pin to be an output and you turn the pin on, it's going to go high. Now, if you switch it to output and immediately start reading it over and over and over again, eventually, due to the capacitance of that line, it is going to stay high for a while, and then it's going to drop off. And the time that that takes is dependent upon the temperature, like the capacitance of the CPU die and of that pin and whatever capacitors are on the die is such that when the temperature is lower, it takes longer for the value to go from high to low. And when it's warmer, it's much more, it's faster. So if I go back to my screen sharing and we do this, I can run this in a debug mode. Just gives me more information. So in this case, it's taken 18,000 CPU cycles to do that. And it's also taken 0.3 seconds. And so I do two measurements. I do one measurement using the time of day clock, and I use another one that uses, does it use raster time? No, it just counts cycles, I think. Yeah, it just counts cycles. Actually, let's take a look here. Maybe I can find it in the code here. So this is on GitHub. I'll show the link later. But print temp. So if we go into the code here, here are some conversions that I do. And where is it? I believe it is time of day clock. Yeah. And then, yeah, it counts cycles. Yeah, that's right. Okay, great. We can get out of here for now. So what happens is if it takes too long, it needs to count it in seconds because it can be quite a few seconds. When it's like 10 degrees Celsius, it takes like 4 seconds. After it starts warming up, you have to measure it in cycles because it doesn't take as long. But one of the neat features of the screensaver is that you can go, it is what, enable temperature? No, temperature enable. No, let's enable temperature. No, I was wrong. It is temperature enable. And now when it runs as a screensaver, it'll show you your CPU temperature. So this is all well and good, but if I stop screen sharing, I may be able to rotate my monitor around and show you on some real hardware. So just to show you here, I've got the real Commodore MSD SD2, and I've got the monitor here. And we're going to try to quickly, while the machine has been off and it's cold, if I can quickly do it, I'll be able to show you here. So here we go, load. See, this is what sometimes happens when I'm running Jiffy DOS and the SD2 at the same time. It fails at first, but then it works. I don't know why. Part of the reason why I use device. So here it is running on real hardware. And if I go temp, you'll see it says 21 degrees Celsius. So if I go like this, no, sorry, wrong one. Now you'll see the temperature is going up because it's running. And in fact, if I were to run the temperature command, in fact, here's what I'll do, hotkey, and I will set it to hotkey number 7, and I will go temp with debug mode. And now every time I hit F7, it will run with debug. I know it's not great in terms of quality here, but this says temperature 26, cycles 24,000, and so seconds 1.7. So if I run this over and over again, you'll see that the time is going down and down and down. It's just a little hard to, it's a little bright. I don't know how to fix that. Does that help? I don't know if that helps or not. But in any case, if you can see that, it says now it's at 29 degrees Celsius. So I've tested this with my thermal camera, and that's where I developed the lookup tables for these values. And if you're interested, again, you can go to the GitHub page, which you can find on my GitHub. So that is, so Chiron B on GitHub, and then chiCLI. It's chiCLI, not chiCLI, absolutely not chiCLI ever. chiCLI, and all the source code is there. I don't have a make file, I just have a little make script. It doesn't, I haven't done it on Windows yet. Maybe at some point I'll make a Windows one, but it's pretty straightforward. If you poke through things, you can figure out how to do it. And yeah, all the source code's there. It's GPL. So if you're in the program itself, you can even go version, and it'll show you within the program, the GitHub link, and it'll even show you the license and when it was compiled, the date and time and everything. So there we go. I think that's a pretty good overview.
Perfect. Thanks a lot, Karen. I think there were a couple of questions. One of them was actually the link to or the URL, but you just gave it back, and it's also on the agenda. So for people looking on the Commodore User Europe web page, you have it there.
Great, and I'll paste it right now.
Yeah, that would be perfect. And I saw, how well does this work with Pi 1541?
It works well. I don't have a Pi 54 yet, but I know someone that has been helping me with testing. And if you actually, here's what I'll do here, one sec. If I go back to screen sharing, if you look on the GitHub page and you scroll down, you'll see here's a bunch of quotes from people who are very happy with it. And if you look under hardware, Pi 50, so on real hardware, the Command HD and the Pi 1541 was supplied by this person. Raj did a great job. Thank you very much. And this has notes for people who have helped with the testing, and we'll give you some notes. The other thing you can do if you want to know about hardware is if you type help, you'll see one of the shortcuts is actually for a different mode of operation for help. You can go help and then hardware, and that will show you the hardware that's supported. And it has some notes. And if you want, let's say, even more information, so you can go help SD to IEC and then -H for hardware. And it's going to pull up a different entry from one of the help files, and it'll show you which commands are supported and which are unsupported. And that's separate from command help. So for instance, if you go command SD to IEC without the -H, it's just going to give you the entry for the command called SD to IEC, which executes the special SD to IEC functions.
Really nice. I see a lot of nice comments like, I like this, I want this. That's pretty good. I don't think that there are more questions in the chat, but I have a few. I think at the beginning you mentioned, so okay, it's detected like NTSC or C64C, etc. So it's not in the configuration. So when you run it on the real hardware, it will also detect. How on what is that based? You make an inventory of the chips, or how do you get to detect the real hardware?
Yeah, sure. Well, I can even show you a little bit too here. If I go into the source code, let's see here.
Or you can just explain. I mean, just looking at the.
Yeah, no. Sometimes I need the reminder too.
Okay.
Let's see. So if I go to the sysinfo command, it runs a bunch of other commands. So the first thing that it does is it detects the SID. And based on looking at the SID, it can figure out if it's the 9-volt or the 12-volt. So the Commodore 64C or the 6581 original SID. It doesn't detect any other kinds of SIDs at the moment. I'd like to add support in the future, but again, I gotta find more room somewhere, which means I'd have to optimize. So, and it uses that to determine if it's a 64C or a regular 64. And based on that assumption, it's going to then assume that because it's a 64C, then it's going to be this VIC and et cetera, et cetera. To detect NTSC, I look at there's a byte in the kernel, and whatever you found online is actually not correct. I found the best byte. There is one byte in the whole kernel, which is really good at detecting whether or not it's an SX64 or what version of the kernel it is. Again, this is all in the source code. Like if it's an Educator 64, whatever, there's one byte that is the most unique byte in the kernel for determining that. So that's how I detect the kernel. For NTSC, I used to use the kernel to detect it, and I can't remember. I think I still use the kernel to detect it, but there are better ways to do it. That was just the shortest way to do it, so I could fit as many features in as possible. It also looks at so it looks at the kernel, it looks at the SID, it looks at, for example, it'll detect if it's a the C64 Mini or the 64 versus Vice. And that's because both Vice and the C64 or the C64 Mini set up RAM in a default pattern. So I look at the pattern of RAM and then use that to determine, for example, if it's emulated under Vice or not. Now, in Vice, you can set the memory pattern to be, and in fact, I talk about this in the code right here. But if you look at Vice, there is an option you can use to change memory to whatever you want. So if you did that, then you very much could obviously trick my program into not knowing it was being emulated. So again, it's not bulletproof, and that's not the goal, but it's pretty good. It'll detect SX64, Educator 64, all the different PAL, NTSC, C64, C64C, the earliest C64s. If you're running on a 128, it will, in 64 mode, it'll detect that it's a 128, or if it's a 128D, or if it's a 128 DCR. What else? It detects MR as emulated. I don't have a MR. I know someone who's helped me test it with the MR. So it usually just comes up, I think it comes up as Vice. I'm not sure. If I had a MR, I'd poke around and find a better way to reliably detect it. But so I use a variety of tricks. And again, I try to come up with the least amount of code, the tightest way to do it possible. So again, I can fit in as many commands and features in as possible. Oh, and by the way, the 64 that I've been running right here, you can see is now at 40 degrees Celsius. So it's been slowly getting hotter and hotter. Fun fact, if you don't have a heat shield on it, it can be, it can get as high as like 65 degrees Celsius, and the spec sheet says it shouldn't be hotter than 70. So, you know, having something to, at least the heat shield or something might be a great idea. But I didn't realize how hot it would get if it were completely naked and nothing was going on. So, and the accuracy is a couple of degrees. It's not perfect, but it's pretty good. I'll probably refine it. I recently had to fix a bug, but the temperature detection, it works a lot better than I thought it would.
Okay, really, really good. Maybe another question. So now it looks really like a subset of commands that we have normally in the shell or something. Is it possible to write? Because I mean, the day-to-day usage of it would be like manipulating files and these kind of things. Is it possible to write batch files and to use pipe? Like if I want to read the content on a certain memory allocation and dump that into a file or something like that. Can I do that? Does it is it possible to use pipes and these kind of things?
Right. So that's a two-part question. So the easy answer is I wrote a command that will dump memory to a file, but at the moment it doesn't use pipes or run batch files. However, I had that in mind from the beginning. And so perhaps I'm at version 1.06, I think right now. Maybe a version 2 might have the ability to run a batch file. I'd like to be able to do that, but again, every version I release is maxed out in terms of RAM. Like if I go in to fix a bug and I do like one printf statement to barf out something for debugging, it'll be like, nah, you ran out of memory, and I got to go disable some command or something to temporarily make room to debug it and then fix it. And then if I still have enough memory, great. If I don't, I'll have to find somewhere in the program I can optimize something or make a little room or something like that. So so it would already have the batch file thing if it were easy to have more room. But no, the pieces that are needed to do the batch file thing, I think most of them are there. It would probably be a numbered kind of batch file. So it would, you'd have to put line numbers in the batch file. I think that would be the easiest way to do it, but maybe not. Anyway, it's on the horizon, no promises, but it's definitely something I'd like it to be able to do, but it doesn't do it at the moment.
Okay. Oh, good to know that we will follow, this project on your GitHub page. I don't see more questions. I think for the moment. So thanks a lot.
Thank you.
I think I will then close the not close, but stop the recording. And now, where is this? Is this here? Okay, I stop the recording now. In case there are more questions coming, maybe people put it in the chat, and then you can retrieve it from there.
Sure. Sounds good.
And then I have so next coming up next then is Marcus. Marcus, are you still there?
Yes, I'm here.
Yes. Marcus, can I ask you something? Do you have any issue on switching with Hugo, because Hugo has an appointment and we are now running quite late, and it would be nice if possible that he would go first, if that's possible for you.
Yeah, sure.
Okay. Thanks very much for that. Really, thank you, because we are running late, and it's yeah, different type of different time over there. So thank you for that, Marcus. And then Hugo, if you want to go now, then please, the floor is yours.
Thank you very much. I really appreciate it. I'm going to share my screen. So hello everyone. My name is.
Just a second. I will start the recording.
Right, the recording. Okay. Thanks.
Yes.
So hi everyone. My name is Hugo. I'm here to tell you about a game that I wrote, a text adventure called Tristam Island, and then I also translated it into French just last year as L'Île Tristam. I just wanted to talk to you about it and a little bit about the tools that I used, because some of the tools you might not be aware that because they're very new, and if you want to write your own text adventure for Commodore 64, there's really some great things you can do with those kind of systems. I'll just start by introducing myself because I'm a little bit new to the community. I'm mostly a writer of text adventures. I wrote like a couple dozen of them, but also other kinds of narrative games. And I have never owned a Commodore computer. It's just during the pandemic that I really started digging into all the retro computers. I installed Vice for the very first time, and I learned a lot about the Commodore computers. And I wrote the text adventure, just kind of discovering the tools, and I had a lot of help from great people as well. So yeah, really my passion, I guess, was text adventures. I discovered, so I was playing point and click adventures in the 90s, and then in the early 2000s, I discovered the text adventures, and it was very good for me because I can't draw anything. So it was a good way for me to make my own games, and it's really quite the active scene in terms of writing. So different settings, different puzzles, different concepts for games. It's still quite active. And then as I started exploring this, I also realized that, so I'm French, and there hasn't been really much information or articles or anything that had been written about French text adventures. And so I called a few people, I did some interviews, I kind of tried to gather information about all the text adventures in French, which involved playing a lot of Apple II games, but also a few Commodore 64 games. And then the last couple of years, I kind of expanded, and I now have a English language newsletter on retro text adventures. It's just the more you dig, the more information you find in this, and it's really, yeah, it's really fun. So the game that I wrote, Tristam Island, came out in November 2020, and it was released for 36 different platforms, which includes basically all the Commodores. It's also compatible with Amiga, with the Atari computers. There's also some weird platforms like the Dreamcast in there as well. And the concept of the game was really to make something that was inspired by the Infocom text adventures. I used the tools developed by Infocom, and the feel of the game, I really wanted to make it just like the Infocom text adventures because they're great. So it's a game that's set on a deserted island, and you try to survive and you uncover more and more secrets. It's about 6 to 7 hours of gameplay. And this is what it looks like. So on a stock Commodore 64, this is the game, which like that's literally the first screen that you see. And so as you see, there's no graphics, it's purely a text adventure. But I tried to use as much as possible the format and try to cram as much game as I could, which, I mean, I'll get to that a bit later. And the game was pretty well received by magazines, so I was really happy with that. I got the Sizzler Award in Zap64 magazine. I also got some very nice write-ups in some Amiga magazines and the Apple II magazine as well. And the players also started sending me pictures of the game working on all the different platforms. So as you can see, there's here Commodore PET, there's the Commodore 128 to the left, and then Oric on the right. And it was really quite a bit of work, but I can't take too much credit either. It was mostly trying to talk to the right people and trying to find how to make this format work on as many platforms as possible, using Infocom's tool and using some other programs that had been developed by different communities, sometimes in obscure forums and things like that. Oh yeah, and then last year, I translated the game into French, which was also kind of difficult because all the engine and the interpreter programs on the different platforms, they mostly didn't really support accents. So accented characters were a major challenge. And there was also problems on the space that you need. Like, kind of already had maxed my space in writing the game in English, and then I translated it into French, which is kind of a more a language that requires more letters, more words for the same information. So I kind of had to find ways to optimize everything. I won't go into the details, but it was a very big challenge to translate it into French as well. But it's done, it works. So very happy with that. And so here's a little bit about the tools that I used to do this. And first of all, I just want to mention there's a lot of people that helped me. So Infocom, 1980s text adventures, and the way they did it is that they had an engine, an interpreter program that ran games on a specific format. And then Graham Nelson found a way to make more games in that format. Andrew Plotkin fixed a few bugs last year, which meant that it was possible to target 8-bit computers and things like that. Frederick Ramsberg and Johan Bernson did a lot of great work, especially in the Commodore 64 aspect, to help create those games. And Stefan Vogt was also writing a game at the same time as me, and he helped me a lot with getting it to work on a few different platforms, and we kind of bounced ideas off of each other. So yeah, a lot of people helped me really. And yeah, I kind of alluded to that, and maybe that's something that you already know, but just in case. So when the Infocom games came out in the 1980s, the format that was used is that they had a virtual machine, meaning that they defined a set of instructions or virtual instructions, and they wrote the game file using those virtual instructions. And then all they had to do is create a program for each platform. So one for the Commodore, one for the Amstrad, one for Oric, et cetera, et cetera. And this program would take those virtual instructions and translate them into actual instructions for the processor, right? Which means that you write this kind of interpreter program just once when you want to support a new platform. And then after that, all you have to do is write the games in the right format, and then just put the games on the floppy. There was a few different formats, and things can get a little technical, but basically all you need to know is that the basic format, the one that was used by Zork, Planetfall, Suspended, all kinds of games like that. It's a format that was that has a kind of harsh constraint in terms of space. You can only have 255 objects and 128 kilobytes of data, which includes the object definition, the connections between the room, the text that you actually display, and things like that. And then in the late 80s, they had a different format, kind of an evolution of the Z3 format, which is Z5, which made games bigger, and they had a little bit more effects. So it's things like Trinity and Border Zone and things like that. But this means that the Z5 format doesn't really run on every single platform. If I remember right, I think for the Commodores, most of the Commodore supports Z3 and Z5. But if you look at things like the TRS-80 or even the Oric, they only do Z3. So I went with Z3 when I wanted to create my game, because I wanted to make it available on as many platforms as I could. But this meant then that I was making things harder for myself, right? And then the tools that I used, so Graham Nelson wrote a programming language called Inform, and there's a lot of great documentation online. There's a designer's manual, there's quite a bit of tutorials and books that have been written on this. And once you write your game using the programming language, you have a compiler that converts it into the right format, into Z3 or Z5. Then all you have to do is grab your copy of Zork for the Commodore 64, and you take out the game file, which usually it's called game.dat or something, DAT or something like that. And you just replace it with yours, and then you just put it in your Commodore 64, and it just works. There's not really anything to try to dodge a copy protection or anything like that. If you swap the game files, it just works. But it wasn't, so that was 1993 when this tool came out, and it kind of created, like, there's thousands of games that were created using Inform. But it wasn't until 2022 or maybe 2019, 2020 and 2019, that the tools were refined so that really the games could be made more playable on 8-bit microcomputers. A lot of it is the work of Frederick Ramsberg and Johan Persson. They wrote a library for Inform that was optimized for 8-bit computers, meaning really having, like, making sure the code is very optimized, very fast, and things like that. Basically, if you wrote the game using the usual Inform library, the game would run, but it would be slow. And in the parts that is taken care of by the library, which is how to recognize the word, how to parse the input, how to match it with the different verbs, different actions, and things like that, this would take a lot of space. And then you would have just, like, I can't remember, but you have, I think it used to take 70 kilobytes, and then you have 50 kilobytes to write your game, whereas Puny Inform takes 23 or 25 kilobytes, meaning you have basically 100 kilobytes for your game, which is much better. And then Frederick and Johan did also a second thing in parallel. They created Osmu, which is a great interpreter for Commodore computers. So this is available on their GitHub. And this means that you can just download this and find any game file that you want, so Z3 or Z5 or even Z8, the bigger formats, and play them on your C64 or sorry, the C64, C128, the +4, and also the Mega 65. So quite a few platforms taken care of by this this great program. So yeah, once all these tools, and I helped with Osmo, and I helped with Puni-Inform quite a bit to try to develop this, and all the while I was working on the game. And the way that I did it is kind of the way that the process that I have for text adventures. I usually draw a map first using a great tool called Tristam. I'll put the link a little bit, I think in a couple slides. Then you have to figure out the plots and the puzzles, how they kind of chain to into each other, what kind of things is the player expected to do in which order, things like that. The aspect in the game design, I wanted to make a game that was nicer than Infocom, as in it wouldn't lock you out, it wouldn't just kill you kind of arbitrarily or make you lose your save. Just something that you can just focus on the exploration and take your time to unravel the puzzles. But what I hadn't really considered is that this idea, these graphs that you see, they actually translated to a very big game. And so there was a lot of work and a lot of sweat involved, and I had to develop my own techniques and things like that to make it fit within the constraints. And as you see at the bottom right, that's the result of compiling the game. You can only have 255 objects, and I used 254. And then there was 2 bytes free at the end. So it was 128 kilobytes minus 2. So yeah, a great experience, lots of learning, but very, very complicated as well. And this is a part of the talk where I point up the camera and say, what I did, you can also do it. And I'm going to tell you how. This is going to be like a lot of names and a lot of links. So maybe you want to take a screenshot, or maybe you'll look at the recording on YouTube later. But this is how you would go about making your own text adventure for Commodore using the tools that are compatible with Infocom floppies. The first thing is you need to start using Inform 6. So you need the compiler, which is on David Kinder's GitHub. And then you can find a tutorial. So for example, the Inform Beginner's Manual is a 200-page book, I think, but it really takes you by the hand and makes you do, I think, 3 different full games of increasing complexity. So it's a great resource to start. And then you can also download the Puni-Inform library on Johan's person GitHub, which again makes sure it's basically the exact same functionalities as other libraries, but it's much faster, so it'll run better on your C64. And then the build tools here are Stefan Vogt's script to, once you have the game, it just kind of puts it all together, generates the right disk files for like I think 25 different platforms, including all the Commodores. Or if you want to do it more by hand, you could download Osmo by yourself and generate a disk image from that. And the last link is Tristam, is the tool that I use to kind of plan the game, make a map, and get an idea of what would be in the game. So it's more on the design side than on the actually making it work on the Commodore, right? And I also wanted to mention that you can also do it on Amiga. I have a good friend of mine who actually created a whole text adventure on his Amiga, and he was able to do that because the Inform 6 compiler has been compiled for Amiga. There's a package available for it, and then you just have to download the libraries and put it all together. So you can create it on your Amiga and then play it, of course, on your Amiga using one of the many interpreters that exist for it, FROTS or JZip or Amiga Zip, and there's a few of them. And really that's it. I just wanted to wrap up with, if you don't necessarily want to use the same tool as Infocom, or if this Inform 6 language is a little too complicated or you don't want to get into this, there's other tools that allow you to create text adventures on Commodore 64. For example, the Quill. So probably a lot of you know this already. This is a tool that came out in 1984, I think, for the Commodore 64, and really a bunch of other platforms. And the way that it works is that you work on your Commodore 64 through a series of menus that allow you to define the locations, the text, the objects, the triggers, what happens when you pick up this object, the conditions, like you have to have this object to pass this door, things like that. There's an extension or an add-on that was released in '85 that allowed you to add graphics. So the Quill, like the basic Quill software, allows you to do some text-only games, and then you can use the Illustrator to make it a graphical adventure. So it's quite a neat system. There's not really a very complex programming language to, not that Inform 6 is very complex, like it's kind of an object-oriented, very nice language, but this is basically no code if you want to use the Quill, but it does make for adventures that are a bit simpler in terms of less vocabulary, less text, and things like that. The memory is a little bit more constrained. But I do think that you can, using the Quill, you can write games for the tapes, which Infocom's games are usually disk-based, but the Quill also allows you to do tape-based games, I think. And then the other tool, so that's also actually a very neat story. In the late 1980s, there was a Spanish studio called Aventuras AD. They were basically the Spanish Infocom. They made some great text adventures. And they did that using an engine that was developed for them by the creator of the Quill. That engine was called DAD, or DAD, and it allowed them to make graphical text adventures. And then in the, I think it was in 2015, where everything was found and uploaded and preserved, and people started working with this and making modern tools that allow you to target this kind of, formats, right? So that's the tool that's called DAD Ready. You can find it at this address, and it's a little bit of a programming language, but not too bad. Kind of simple conditions and prints and things like that. And if you edit a text file, edit the right text file in the DAD Ready directory, and then put your images in the right directories as well, then you have a bunch of scripts that will allow you to generate your graphical adventure for the C64, but also for, I think there's Spectrum, MSX, Amstrad, Amiga, things like that. So it's quite a nice tool, and this picture is a picture of Stefan Voigt's game from 2019 called The Curse of Rabenstein. That was the first game that was written using the DAD Ready framework. So yeah, I encourage you to look at this as well. And really, that's all. I just wanted to kind of show you all those cool tools and talk a little bit about how I created my game. If you want to find it, you can find it on my either on my website, hlabrande.fr, on my itch account, so hlabrande.itch.io. You can always reach out to me on Twitter at hlabrande if you have any questions. I'm happy to help. Yeah, thank you.
Thank you, Hugo. I'm looking here in the chat if I see any questions. I don't see any questions, but I think one point maybe. I mean, you explained a lot about how you created the game. That's really nice. But if you had to, I mean, to pitch the game, explain us a bit, just to give us, just to tease us with the game. How would you describe that? And can you say maybe what is the, I don't know, the time expected to one can expect to complete the game? Is it how many options, or how many paths do we need to, how many screens are there, or something like that?
Yeah, for sure. So the game is you just start on the beach, wash the shore after an airplane crash in the middle of the Atlantic, and you're on a deserted island with not really an obvious way to get out of it. So the first part of the game is kind of exploring the island and trying to find a way to eat and a way to sleep, kind of classic stuff in a deserted island kind of scenario. But the island has, if you climb up the island, then you eventually find that there's traces of life, that the island used to be inhabited by quite a few people. And there's hints that something went wrong on the island and that everybody had to flee, to run away. There's a big white house on top of the island, which is an obvious reference to the Zork game, but also this is the place that you want to try to break into, and that's where you'll uncover the final secret of the island. It's about It's quite a long game, I guess. It's 6 to 7 hours, I think. I have a free demo that's just the first part, so exploring kind of the lower level of the island and trying to find food and trying to find a place to sleep. That's about maybe an hour and a half of gameplay. So you can just download this and see if you like it first before you buy it. The game is priced at just $3 or $4, so it won't cost you too much anyway. So yeah, 6 to 7 hours of gameplay, and I think I have something like 70 different locations to explore. And again, there's several, like there's the lower level of the island, and you manage to go up and you explore some more, and then you manage to go inside the house and you explore some more, and you find some secrets in there and things like that. Yeah, 70 locations, and the rest are just the objects that you can pick up, that you can look at, you can explore the different clues, and there's I think about 20 or 25 different puzzles to solve. And it's not, I made my best to make it not linear. It's not just like you are blocked until you can find the answer to this puzzle, and until then, well, you're just got completely stuck. I try to make it nicer, and so you can work on several different problems at the same time. Because sometimes it helps, right? You're stuck on something and you're just like, okay, I'm going to look at this other way to do like this other puzzle, and then you have this idea about the other one, and you just run back at the other side of the island, things like that. So yeah, and that way I try to make it really nice and playable for players to not get stuck and to not lose their progress or something like that. Yeah, there's an intro screen, I guess, that you're staring at right now. Probably it looks better on a CRT screen. And what else? Oh, I think that's about. Oh yeah, maybe there's when you get the full game, you also get some clues, some Invisi clues kind of package. Kind of similar, except it's all digital, of course. So I couldn't do like Infocom had the actual physical books where you had to look at the clues and rub them off or something like that. So it's a little bit different, but you have a digital PDF that gives you clues in case you're stuck. I haven't had too many players reporting that they're absolutely stuck on a puzzle and they really need help. But if you ever are, you can always send me a message. I'll be happy to help you.
Okay, good, thanks. And then you said so you can download a kind of demo version, and then otherwise you need to buy it. And do you get it like a physical copy, or is it just the download on what is it, on Aminet or something like that for Amiga? And
so I mean, on Aminet I put the demo. I also put the demo. I think it's on the I can't remember the big C64 website as well. But the demo is, and the game so far are just digital. I'm hoping to have physical copies, like a physical version made. I'm in talks with a publisher, but it hasn't been done yet, right? So maybe late 2022 you'll be able to buy an actual physical box copy of it. But for now, it's just a digital download with a low price.
Yeah.
So.
Okay, oh, which is nice. Okay, can you just put maybe, I don't think that there are more questions, just one. Chiron is asking if you can show the Amiga links again. Maybe you
for
can
sure.
also,
Yeah.
and then, yes, okay, Eduardo is asking digital download at which site. Maybe you can copy the links if you still have a few minutes in the chat. Yes, please.
Yeah, so for Amiga, this page is kind of an old version of the Inform6 compiler. And I have a friend who took basically the latest version. So it's C code. So really, you can just compile it on Amiga and it would be okay. I just don't have the binary. I don't know where to find the latest binary. But it's somewhere. And if you're okay with just downloading the code from GitHub and compiling it on your Amiga, it should be fine, right? And then where can you find the game? I guess I will copy and paste that link and put it in the chat.
Yes, please. Yes, thanks a lot for that. Good, thank you, Hugo. I will stop the recording now. And then, yes, finally, Marcus, sorry you had to wait, and we are really delayed today. Are you still with us, Marcus? Well, I see your name, but
Yep, I'm here.
perfect. Hello. So I will also share, sorry, not share, but start the recording so that you can tell us more about the orange cartridge. Go to the
Yeah, I'm trying to share.
This meeting is being recorded.
There you are. The floor is yours, Marcus.
Now, perhaps I'm sharing. Let's see. So, yes. Hello, everyone. My name is Marcus Comstedt, and I'm going to give a very short presentation of a simple FPGA cartridge for the Commodore 64 and Commodore 128 that I've made, which I call the orange cartridge. So I'm going to jump straight in here and show you this schematic representation of what this cartridge looks like. So at the center here, we have the FPGA itself, which connects to every signal on the expansion port of the C64. And the FPGA I've chosen is a Lattice ECP5, which is a simple and affordable FPGA. And the nice thing about the ECP5 family is that it's supported by the open source toolchain called SymbiFlow. So you can actually create bit streams for it using only open source code. And this FPGA, like many other FPGAs, it can't use 5-volt signals directly. So there's also some level shifters down here, which convert the 3.3 volt signals from the FPGA to the 5-volt signals on the expansion port. Then there's some additional stuff to support the FPGA. We have some flash memory here for storing bit streams. There is 60 megabytes of RAM. There is a USB connector that you use for uploading new bit streams. And there is a micro SD card connector that you can use to load and save data to SD cards. And there is a push button and an RGB LED. There's also for debugging a JTAG interface and a serial port. And I also added, for good measure, a clock port connector so you can connect peripherals like the RRNet Mark III Ethernet module. Right, so moving on the top picture here, you can see the first prototype I had manufactured in August last year, just to test if this design could work at all. And it turned out that it worked just fine. So after trying out this prototype, I went to Kickstarter to see if I could interest people in maybe a manufacturing run of 50 units. Because when you manufacture electronics like this, the price per unit goes down a lot if you can make a run of something around 50 or 100 units. This particular board at 50 units, it comes to about 120 euros, complete manufacturing and the components and everything. So that's a sort of reasonable price for something of this kind. And apparently people thought so as well. So the Kickstarter campaign was successful. I got people interested in these 50 units. So now they are being manufactured in China by Seed Studio. Currently, there's a pre-production run going on right now. And I don't have the actual cartridges back from China yet, but this lower picture is what they're going to look like. So I made some minor changes from the first prototype. There's a bigger push button and LED for using the cartridge inside the case. And I added some extra GPIO connections for expansions and the USB port has been changed from Mini B to a USB-C connector. Yes, so what can you do with this cartridge? Well, I'm going to show you a gateware project that I'm currently working on, which I call the RVCOP64. So the RVCOP64 is a RISC-V coprocessor for the C64. And to build this, I'm using something called the LiteX framework. And this is a Python framework, which allows you to take different modules and connect them together to form a complete system on a chip. So the LiteX framework provides you with some of these modules, and you can make your own. And one of the modules it provides is a 32-bit RISC-V processor called VEX RISC-V. So this is a 32-bit RISC-V processor. So the 64 in RVCOP does not stand for 64-bit RISC-V. It's a coprocessor for the C64. But it also runs at 64 megahertz, so it could stand for that as well. So this softcore, this RISC-V processor, it runs at the same time as the 6510 inside the C64, and it can access the memory space of the C64 while the 6510 is running. And the 6510 can also access the memory space of the LiteX system on chip. In addition, the 6510 processor can control the RISC-V processor by, for example, accessing the internal CPU registers. It can halt it on single step and so on. So internally, it looks like this. We have this RISC-V core. The core has 4 kilobytes of instruction cache and 4 kilobytes of data cache. And if there is a cache miss, then there will be memory accesses that go out of the caches and into this bus interconnect, which is a standard LiteX component. And then there is on the other side of this, a 4 gigabyte address space, so 32-bit addresses, which is divided into different parts. So here we have, for example, memory mapped control and status registers, which give you access to peripherals, like, for example, the SD card reader. Then there is RAM internal to the FPGA called block RAM. There's also some of that RAM is made read-only, so it's acts as ROM, and this ROM contains a BIOS for the RISC-V processor, which comes as standard with the LiteX system. And this BIOS has a command prompt that you can give some commands. Next area, we have the external RAM, 16 megabytes. And finally, there is a 64K region where you can access the memory of the internal memory of the C64. So any memory accesses that goes to this area turns into DMA cycles going down into the expansion port. From the expansion port, we can also get requests from the 6510, for example, for a low ROM. So here there's more internal RAM, which acts as ROM to contain some support code. And then you can get I/O accesses via the I/O1 range to CSRs that are explicitly for the 6510. So here we have to start with a virtual UART. So it's a sort of fake serial port. And this is connected to another fake serial port, which is in this area, the controller states registers for the RISC-V processor. And here is where this command line interface of the BIOS uses. So by accessing this virtual UART, you can get access to the prompt of the BIOS, which I'm going to show you in a little while. Then we have this debug stuff, where you can access the register contents and halt and single step. And then we have this part, which creates wishbone bus cycles. Wishbone is the name of the internal bus in the LiteX system. So from here you can make read and write requests to access, for example, the content of this 16 megabytes of external RAM. Right, so now I'm going to show you a demo of this running, if I can get it to work. And I have to apologize that this is not going to be a live demo. I did make an attempt to hook the C64 up and live stream it using a PyKVM, but that didn't work out, so it's going to be a pre-made recording. Let's see, I'll stop this and yes, okay. So now when the 64 starts up here, we will see that this support ROM has added some extra commands to basic V2. And one of the commands is the terminal emulator, which connects to the virtual UART. So here we get the BIOS prompt of the RISC-V processor. And we can look at what are the memory regions available. And one of these is the C64 memory space. We can access, for example, the border color register like this. And it also works in the other direction. So we have the rvpoke and rvpeek commands, where I can access the 32-bit address space of the LiteX system. In this case, it's the base address of the 16 megabytes of RAM. So we write some stuff into the RAM, read back, and we can also check it from the RISC-V processor. And there's the data. So what I'm going to do now is to load some RISC-V code from my floppy. And it's going to be loaded into the main RAM of the C64 to start with. And then from there, I'll transfer it to the external 16 megabytes of RAM and have the RISC-V processor run it from there. So I'm using the rvstash command to transfer the data. And to the start of the external RAM. There we go. And then I'm going to load something for the 6510 to do as well. So this is a interrupt-driven SID tune that I'm loading. And I'm going to start it up. There we go. And then I use the rbsys command to start up the code I loaded for the RISC-V processor. So now everything on the screen is done by the RISC-V coprocessor, including the raster meters, and the top lighter gray raster meter shows the time it takes to actually render each screen, while the darker gray is the time it takes to push the pixels into the main RAM of the C64 over the bus. This quits after 2 revolutions. I'll just start it again. And as you can hear, the SID is playing, so the 6510 is running in the background. And actually, I have the basic prompt. I could give basic commands now if I wanted to, but I don't see what I'm doing because of the graphics, so I'm not going to. But as you can see, the processors run in harmony, so to speak. Yep, so that was the demo, and I should go back to the presentation. Let's see there, and yes. So finally, I'm going to show you some links here. First, the Kickstarter campaign. You don't have to write this down because the link is also on the Commodore Users website. So the Kickstarter campaign is already finished, which means it's not possible to become a backer right now. I'm not using a pledge manager for this small project. But you can read all the updates. Everything is open to read. There are no backer exclusive updates. And if you think that you would like to have an orange cartridge for yourself, you can send me a personal message on Kickstarter. And then I'll know that I need to make some extra cartridges because the main production run hasn't started yet, so it's not too late to add some extra. Then we have some GitHub repositories. First, there's the hardware, so the schematics and layouts of the cartridge itself is available as a KiCad project. So everything about this cartridge is open source. It's open source hardware, it's open source software, it's all the tool chains are open source. Then next repository is the RBCOP, the coprocessor. This is very much a work in progress, but you can see how it develops in this repository. And finally, because this toolchain is open source, it can be compiled for the Raspberry Pi. So I've actually prepared a SD card that you can run on the Raspberry Pi 3 or 4, which has all you need to compile the bit streams for the RVCOP 64 on the Raspberry Pi and upload it to the cartridge via USB. So yeah, that's what I had. Let's see if I can get back to this. Yes, and I'm back. Okay, that was it. Thank you. I think everyone has fallen asleep now.
No, I was just muted. And I have some echo here. Sorry. Unfortunately, my connection went down, so I went to an alternative 4G. So I did not. I haven't seen. Shit, I have more echo. Maybe it's muted. Yeah. Do you also hear echo when I talk? Okay. Don't know what's the reason. Maybe not anymore. Okay. No. So I lost actually the questions because.
Yeah.
Yeah, so the only question I see is the one from Chiron. How much? I think that's a question that many people can think about now. So how much is this? Is the cost for the cartridge?
Yeah. So it's going to be around 120 euros for the finished thing. And that's just for the mounted PCB, so it does not include the case. But you can use a standard case from individual computers, so you can 3D print one. I've made models for 3D printing.
Okay, and then I see, could this be used to create a super CPU re-implementation?
Well, absolutely. So if we look at the this RBCOP thing, that uses about a third of the resources which are available in this FPGA. So I think there's definitely room to make a super CPU.
Okay, nice. Can you show maybe, or do you have somewhere an inventory of the functionalities? Because of course I noted down the 16 megabyte RAM expansion, but is there some?
Yeah, so if you go to the Kickstarter campaign, and you select the actual campaign page, then there you'll see this schematic of the different parts is there. The extra GPIO pins I added is not there because that was added sort of during the campaign, but it's the same picture that I showed here now.
Oh, okay. Okay.
Yeah. Someone is asking what is used for level shifting. So there's two different things. For the data and address bus, I'm using level shifters which are 8-bit parallel that can be where the direction can be shifted. They're called something 245 T8. But I mean, if the schematics is there on GitHub, you can look at them. But these are dual voltage supply level shifters. So you put 3.3 volt in on one side and 5 volt in on the other side, and then you have a signal to say which direction should the data go. Then for the other signals, they are either going from the FPGA to the bus or from the bus to the FPGA. And the ones that go from the FPGA to the bus, they are all open collector signals. So there it's actually a 5 volt tolerant open collector inverter that I'm using for all those signals. And for the ones that go from the C64 to the FPGA, those use a 5 volt tolerant Schmitt trigger. So none of those need to have dual power supplies. They are 3.3 logic, which is 5 volt tolerant.
Okay, thank you. I think that was answering the question. Yes, I see the comment. Nice, absolutely nice. Maybe one last question. I don't see more questions. Maybe if there were questions that I have skipped because I don't see them, then please either I would ask people to retype them or to just unmute and ask them. In the meantime, so the RAM expansion. Do you need something specific? Is there a specific mapping, or you use it? How do you make use actually of this extra memory?
Yeah, so to access the extra RAM from the C64 side, I mean it's connected to this internal bus of the Lytec system, so you can access it with this wishbone bus cycle generator. And the way that works is that you write the 32-bit address into 4 registers, and then you have a 5th register that you use to read data out or put data in. So you get sort of 1 byte at a time, and the address can be set to auto increment. So that is what this rv-stash command that I used, it uses that interface. But I mean, you can also, of course, have code running on the RISC-V processor, which transfers data for you. So from the RISC-V, you can just do a memcopy, because from that side you have, because the RISC-V has a 4 GB address space, it can access both memories directly.
Okay, nice. I see another question from Chiron. So I think it's still related to this the power and the level shifting. Are there any speed limitations?
Yeah, so I mean, all the signals which are on the expansion bus, nothing goes above 1 megahertz, right? Because the pixel clock is 8 megahertz. Everything else is on 1 or actually 2 megahertz, because there is the two bus cycles per clock cycle. But anyway, 8 megahertz is the fastest signal. That's the dot clock, and I mean that's no problem at all. These level converter chips, they can handle tens of megahertz without problem.
Good. I see also a nice comment, Marcus. Also, thanks for all your other open source work. So maybe that's something you will come to another time to tell us about.
Yeah.
Good. I don't see any more questions. So I suggest then I will stop the recording. If some last minute questions come up, then people can still post them and you can answer them from the chat. Thank you very much, Marcus.
No, thank you.
And again, also thank you from the side from Hugo. Actually, he was really he sent me a little message that he was really happy that you could switch. Okay, so we are reaching the end of this meeting, just a little bit later than expected. I would say thanks a lot again to all the speakers. Again, if no speakers, then no event, of course. So it's really thanks to you that you guys are bringing this very high quality type of content that these meetings exist. As mentioned before, so all the videos will be posted, all the recordings will be posted later on our YouTube channel, and the live meeting will be available immediately on Facebook for replay. And then, last but not least, the next meeting is then scheduled on, I need to check on my slide here, the 11th of June. So that will be next meeting, 11th of June, 2022. So if you have any new projects that you want to explain or present, make yourself known about and promote the work you've been doing, or just share about information about new versions of existing stuff that you've been enhancing since the last version, don't hesitate, just get in touch and we put you on the agenda. If no more last minute comment or question, then again, thanks everyone. Thanks again to the speakers, and see you next time. And I wish you a good end of day or afternoon or good night. Thank you very much. I will close now the call, and that's it. Thank you. Bye-bye.